So let's take another look at the reliability QoS policy. In this case, we're going to look at it in terms of how to deliver state or status data. So reliability for state or status data. First, for state or status data, you are going to want to enable reliability. Basically set the reliability kind to reliable. This will turn on the reliability protocol so that if the data is lost, DDS will detect the loss and then send a repair packet to make sure that the state or status data is received. However, you may not need all the values that were sent. Okay, so if you're getting a stream of values, you may only need the most current value, the last value that's published. And then you have different use cases. Of course, for some state or status data, for some use cases, you may want all the data. For example, if you're logger, you're basically doing a black box recording, you're going to want perhaps all the data that was sent. But an application that's basically in controlling the system may only need the most current value of the state or status. So how much data that you get, how much reliability do you have, is controlled by the history QoS policy. So it can configure how many of the published values, how many of the data samples that are sent need to be received reliably. So let's take a look at the configuration of keep last reliability. So with keep last reliability, what you do is you set history kind to keep last, history depth to the number of values you want to deliver reliably. In this case, we'll set it to 1. And don't forget, you also have to turn on the reliability protocol. So with keep last reliability, DDS will send all of the values that a data writer writes. However, DDS will only keep track and ensure that the last value is reliably received or reliably delivered. So on the wire, let's take a look. Right-hand side, we have a publisher, data writer. Data writer sends data. Let's say it sends D1. D1 is sent on the network, and then D1 has been received. That's great. D2 is sent on the network. D2 is received. And note, the publisher only keeps one value in its receive queue, in its send queue, and the data reader only keeps one value in its receive queue. Whether or not the previous data was received, it only keeps one value, the last value. So whether or not the data reader actually saw D1 before D2 came in and overwrote it, it doesn't matter because you have set history depth to 1 and history kind to keep last. So continuing on, you send D3 and it turns out D3 is lost by the network somehow. But before DDS can try to repair D3, you send D4. Now D4 has been received. Because D4 has been received and D4 has been sent, D4's last value that was sent, D3 no longer matters. DDS doesn't care about D3 anymore because you have keep last history depth 1, and we'll just make sure that D4 is received. So continue on, you send D5, you send D6, and you send D7, and for some reason D7 is also lost. In this case, perhaps before you send the next value, DDS determines that D7 is lost. DDS has a copy of D7 and is able to repair it. But no matter what, only one value, the last value, is important in terms of reliability.